Welcome back. So now we are going to do equations. So basically everything we do always leads to doing an equation because that's really what algebra is about, how to solve an equation. So since this unit is all about radicals, roots, guess what our equations are going to have in them? Absolutely, radicals. So let's just dive in and start talking about these. So the square root of 5x plus 1 equals 4. Now we have to be very, very careful on these equations where we put our radical sign, what is underneath it and what is not, okay? Because it can make a huge difference. Now, remember that we've been talking about when the exponent and the index match, then the base of our exponent falls out as our answer, okay? So in order to get rid, because I can't, my ultimate goal here is to solve for this x so I get x equals, but I can't do anything with him as long as he's underneath the radical. So this is a square root, meaning my index is a 2, okay? So I need to do this concept here, get this and this to match. Well, I know what the index is, so let's do this. Now I have an exponent and my index that match means that this guy will fall out as my answer. Actually, let me rewrite this so it makes a little bit more sense. Let's do it this way. 5x plus 1, the quantity squared. And now you can see the base of this exponent is the 5x plus 1. But if I do that on one side of my equal sign, I have to do it on the other. So now on the left side here, my 5x plus 1 falls out as my answer. And over on the other side, I've got 4 squared. That's 16. Now, this is just a linear equation, not a quadratic. It doesn't have a squared anywhere. So I just need to get all my x terms on one side. Well, I only have the 1. And everything else on the other. So that means I need to get the 1 on the other side. I'm going to do that by subtracting it. So that leaves me with 5x on the left side. And 16 minus 1 is 15. And now I just need to get the x by itself. So that means dividing by 5. If I do that on one side, I do it on the other. And I get my answer. Now, here's the thing. We should always be checking our answers, but we don't, and most of the time I let you guys get away with that. But there are 2 times that it's absolutely critical that you must check your answers. One is when we have a variable in the denominator. Remember how we were doing an x cannot be something in the last unit? Well, those we always need to check, and we do it by doing this. And then if x comes out to be 0 in the end, then we know we can't use it, okay? The other one are radicals, because once again, we could have what's called an extraneous answer. It's a real answer to our equation, but we can't use it because of the kind of problem we have. So let's check this, and remember, whatever x is goes back into the original equation. So 5 times 3 plus 1, that didn't come out very good, plus 1 equals 4. I believe that's it. Yep. Okay, so wherever there's an x, I just replace it with what I got for x. And now the square root of 5 times 3 is 15 plus 1. That's the square root of 16. What's the square root of 16? that mean, because these are both, the 4 equals 4 are exactly the same. That's not my answer. Not the answer. All it means is that this answer, x equals 3, is correct. And that's the answer you can give me. Okay? Let's keep doing some more examples. Okay? So I have the square root of 5x plus 3. Let me bring this back. Oops, just a little bit. Plus 2. Now you notice this plus 2 is not underneath the radical. So here's the thing. In order to do these kinds of problems, I have to have one radical term all by itself on one side or the other of the equal sign. Well, this guy is not by himself. He still has a plus 2. So let me get rid of him from this side before I can start this problem. So that gives me, I subtract him from both sides, so it gives me the square root of 5x plus 3 equals -2. Okay, now I can work on getting rid of the radical, but he has to be by himself on one side or the other, doesn't matter, before I can work on getting rid of him. So once again, it's a square root, so I'm going to square this so that my exponent and my index match. Okay, but if I do that on one side, I have to do it on the other. And so then I get 5x plus 3 equals -2 squared is 4. Now once again, this is a linear equation, so I just need to get all my x terms on one side, everything else on the other, and then ultimately x by itself. So I'm going to subtract 3 from both sides, and then I'm going to divide the 5x by 5, and that gives me x equals 1/5. Now I need to check this. Okay, so let's put this in here. 5 times 1/5 plus 3 plus 2 equals 0. Always make sure it's in the original equation. Okay, the original equation. So first of all, this is like 5 over 1, so I can just cross cancel my 5s, and I get 1 times 1 is 1, and 1 times 1 is 1, so 1 over 1 is 1, plus 3 plus 2 equals 0. This is the square root of 4 plus 2 equals 0. Square root of 4 is 2 plus 2 equals 0, and that's 4 equals 0, and that is not the same. So it means even though this is a real answer, I can't use it in this problem. So we bring in the null set. Okay, that's my answer. Let's try another one. 5x. This is kind of funny. They aren't all 5x's. Oops. And this one isn't either. 5 minus x equals x plus 1. So I've got one radical term all by itself on one side. So now I just need to work on getting rid of the radical sign. But here's the thing, guys. We do not just do this, put a square on each of these. It's got to be everything on this side is squared, because there's a huge difference between this and what we've got here, which is a perfect square trinomial, which is x squared plus or minus 2 times x times y plus y squared. So over on the left side now, I've got 5 minus x on the right side. So I take my x, which is my x, because this is going to be my x, and the 1 is my y. So x squared is x squared plus, because this guy's plus. And then I take x times 1, that's 1x, or x, times 2, because that's the middle term. And then plus, because in a perfect square trinomial, that second sign is always plus, and then I take my y, which is 1, and square it, so that's 1. Now, guys, I do have a quadratic equation, so now I need to set it all equal to 0. I only have one squared term, and he is positive on the right side, so I'm going to take these two on the left side and move them to the other side. Subtract 5, add x, so that gives me x squared when I add x to the 2x, and when I subtract, I get this, and now I need to factor because that's how we do it. And let me see, it's going to be a 1 and a 4, and if I make it a positive 4 and a negative 1, when I add these two together, I get positive 3, last critical step. Negative times a positive is a negative, and I'm good to go. And so then now I set each of these equal to 0. Just the same thing we've been doing for many chapters now. X equals 1, x equals negative 4, but now I need to check each of these. So I'm going to check x equals 1, put it back into the original equation, which is 5 minus, and if this were a negative, well, I'll show you on the other one. 5 minus x equals x plus 1. So that's the square root, that guy didn't come out good. Square root of 4 equals 2. That's 2 equals 2. So x equals 1 works. Now let's check x equals negative 4. Okay, and so we get the square root of 5 minus my x. So you notice how I put the minus 4 in parentheses because it's a minus minus equals negative 4 plus 1. So this is the square root of 4 plus 5 plus 4. 5 plus 4, and this equals negative 3. So this is the square root of 9 equals negative 3. That's 3 equals negative 3. So this one doesn't work. So my final answer is just x equals 1. Okay. I'm going to try this one real quick and then see if I have time for the last one that I wanted to do. So the cubed root of 2x plus 7 equals the cubed root of 3x minus 2. Well, I have one radical term on one side of the equal sign all by itself. Doesn't matter what I have on the other. And because this is a cubed root, in order to make these match, I'm going to cube this guy. Well, if I do that on one side, I need to do it on the other. Well, that's nice because now each of these just falls out as my answer. It's a linear equation, so I don't need to worry about setting it equal to 0. I'm going to get all my x terms on one side. So that means over on the right side, because that'll keep it positive. So that gives me 7 equals x minus 2, because I had to subtract the 2x. Now I'm going to add the 2 to both sides. That gives me 9 equals x. I'm not going to take the time to check this one. You guys can do it, because I'd like to do this one last one just to show you. And I only have a minute. 1 minus 2 p minus p squared. I'm just going to zip through this one and see if you guys can follow along. So 1 minus 2p minus p squared. Square that. If I do that on one side, need to do it on the other. 1 minus 2p minus p squared. This is a perfect square trinomial, so p squared plus 2p plus 1. I'm going to add the p's to both sides. Actually, I'll do everything, so that's 2p squared. Oh, I think I'm out of time. Well, if you really want to see the end of this, bring it to me in class.